Yeah, thank you. So from what I have seen the last couple minutes, I think there is quite some overlap. But I will continue, give you my presentation here. And if you have any question, feel free to ask them, or we will have a Q&A session afterwards. So yeah, CAN FD, a vitamin shot for SAE J1939. I guess a couple of the things Thilo has already mentioned. I would like to give you an overview here. I have structured my presentation in an introduction section, then FD J1939 at a glance. Then I will pay some attention to the physical layer. Then I may discuss some migration scenarios and then the conclusion. So what is the motivation for change? So J1939 was there since forever. And it does and is still doing a good job, great job. But as always, there are some issues. And the major issue that we found in the SAE committee is the first one. We identified three major issues with J1939, and the first one is bandwidth. The second one is bandwidth, and the third one is bandwidth. So this is really where J1939 suffers the most. And to overcome this, we had to think what we can do. And the demand for the bandwidth is clearly coming, or we have identified a couple of areas. So the demand of bandwidth and increasing bandwidth is simply because of the increasing complexity and the amount of ECUs. And all this requires more communication, which eats up a lot of the available bandwidth. And the other topic, it's not really new, but it is more and more becoming an issue. It is about functional safety. So it is nearly impossible to do any new application without maintaining the safety functionality, and this typically requires additional payload, for example, transmitting additional CRCs and so on. And this is really, really hard to fit all this in an 8-byte payload. There are several measures inside J1939 to overcome this, but at the end of the day, it is a significant increase of the bandwidth. And bandwidth, again, is really not available, and it's a tight resource, and therefore functional safety is really a driver for this change. And then last but not least, security is probably on the same level than functional safety. Whatever you do by means of security, it will end up in additional payload, additional communication requirements, and this will also cause problems with the bandwidth. So the possible solutions we discussed inside the SAE J1939 committee is that we could certainly increase the baud rate. So currently it is limited to 500 kilobits per second. We could probably go higher, but then the withdrawal of this is that will limit the length of the CAN network. So this looks somehow be endless, and you cannot gain too much bandwidth. The other thing is we can seriously think about packing existing data more efficient. So inside J1939, a lot of signals are transmitted even so that they are not used. So they will be communicated on the network as not available and so on. So we can certainly think about to get rid of this and only transmit those signals which are relevant for this specific network we are talking about. However, this approach has a backdraw because it requires a new protocol scheme, a complete new protocol scheme, probably something like service-oriented and so on, which also would probably be a little bit tricky to put this on an 8-byte based CAN data link. And the other thing is, if we really tweak the protocol, that would certainly break backward compatibility, and then it is more revolution than an evolution, and we will face in the market with a lot of other issues. So all of those possible solutions we have really discussed and thought about seriously is somehow critical. There's nothing for free. And the expectation overall about those alternatives here, the expectation is that all those measures based on existing components will probably not give us the bandwidth that we expect we need in the future. So all of those improvements would probably help, but they would not pave the way for the next 10 to 15 years of J1939 networks. And so it is really not the way the J1939 committee is heading towards. And then, we looked outside CAN. We reviewed other technologies like automotive Ethernet and all those different things. And then finally, the committee decided to go with CAN FD after we really paid a lot of attention to all those other possible networks. And the decision to stay with CAN FD is mainly based on less complexity with physical layer and protocols compared to automotive Ethernet. So the whole industry is used to work with CAN and with this complexity. And so the complexity that comes along with automotive Ethernet, dealing with IP networks with these lot of different protocols, seems to be not feasible for the trucking guys. And so therefore, this was a huge argument here. We want to have smaller steps, not really replacing the complete communication scheme. Because of a simpler migration path, if we go from CAN to CAN FD, it looked at especially at the beginning, it looked that we can really have a very simple and easy migration coming from the old to the new network. Lately, it turned out the world here is not so easy as initially expected, but we will see this later on the slide. And then another thing is that we want to have a dual use. So an ECU should be possible to work on both networks, on the new one based on FD as well as on the classic FD, which would certainly be a higher hurdle if we talk about a device that is supporting Ethernet as well as CAN FD. And then finally, at the end, CAN FD is more cost efficient compared to switch automotive Ethernet. This may be different if we would compare CAN FD with the upcoming Ethernet automotive link with the 10BASE-T1S. However, at the time we discussed those topics here, 10BASE-T1S was not on the horizon, so this was not really a topic we considered. If we would have to start now with all our thoughts, maybe this would have been also a solution, but now we are talking about CAN FD, and those are the reasons. The good thing here and for now is that all this work has been done, and I can say that SAE committee is really proud that we can say, we have already released the documents, so we are not talking about theoretical solutions, so we really talk about practical solutions, and they are ready to build into your devices. So you can starting from today, you can start with the new CAN FD based J1939. So if you go to SAE website and download the document J1939-17 and the J1939-22, then you will receive two documents here packed with all these CAN FD knowledge, and then you can immediately start implementing J1939 CAN FD based protocols. And if you are going to update your existing components, you may consider this seriously. So to really take this into consideration and make the necessary steps that maybe your device can also support the CAN FD extensions. So this is really what the status is today. And of course, if you look at all those SAE documents, and you can see we have released the -22 document in March this year, everything is really fresh. And of course, other documents in the J1939 document series needs to be updated. So there will be certainly once in a while a new compliance test document, which takes all those changes coming with the CAN FD based protocol that would be reflected in new compliance test documents, etc. pp. Yeah, so the good news is you can start right now today and have a look at it. Other documents, so initially, if you look at the history a little bit, so the initial development of those protocols started within the CIA, and then once in a while it has been handed over to the SAE committee. So the previous documents from CIA 602-1 and 602-2, which covers pretty much the same like here, but in an earlier stage, will be replaced by the SAE documents. So please check out the SAE documents. Those are really the documents now that counts in the truck and bus world. Okay, so this is the introduction, and this is really all about it. To give you a little bit more insight, I would like to walk through a little bit to the CAN J1939-FD at a glance. And so the general design aspects, and I guess I've heard a couple of them already within Thilo's presentation. So the idea here is really the efficient usage of the CAN FD bandwidth, and therefore, yeah, we are really going to use the larger frames. So we are not limiting ourselves to 8 data bytes of payload. So the new protocol will take advantage from the extended payload capacity. So the payload, yeah, we are going to use all of these 64 bytes if possible. You will see this is not always possible, but this was one of the design aspects. We use the bandwidth as efficient as possible. As a consequence, the communication with the new CAN FD is limited to really FD-based communication. So the classical extended frames and the classical basic frames shall not be transmitted on a J1939 network. So there is not really a compatibility that you can plug in an old device to a new network and everything will work in parallel. So it is really one or the other. So you communicate FD or on one data link, and you can communicate the classic way on the other data link on the classic data link. No rule without exception, of course. So especially for the address claim procedure, that's really one of the exceptions that we use still the classical extended frame format. And the intention here is to have at least some backward compatibility, and so that a device at least can realize if the address is already used or not. And the other thing is, so there is one, so this address claim might be one way to detect automatically on which data link you are working. So if you attach a device and the device is not aware if it is connected to an old or a new one, he may listen and is able to do an address claim and then figure out on which data link it is connected. So this is kind of this might be kind of an auto detection strategy on your individual device. But in general, the classical extended or classical basic frames are not allowed anymore. Then what is also new and is a significant change is we use the 29-bit or 11-bit CAN ID. And so the 11-bit CAN ID is somehow preferred. So the standard gives you all options, but if it comes down to efficient usage of the CAN FD protocol, you may seriously think about using 11-bit CAN IDs to really use the bandwidth, because there's a difference in if you communicate 29 or 11-bit CAN IDs. And so the change here, if you look at the 11-bit communication in classic CAN and J1939 and CAN FD J1939, then you may know that the 11-bit communication in the classic world is used for proprietary communication. And this is no longer the case. So 11-bit communication is now used for the standard of J1939. It's not only proprietary. However, on a limited base, you still can use some 11-bit CAN IDs for proprietary communication, but it is way more limited than it used to be on the classical bus. So you have enough capabilities to use proprietary or to do proprietary communication, but this is one of the changes. And because we want to use this benefit that 11-bit CAN identifiers provides. The good thing, and this is also something that I've heard at Timo's presentation, is we use the existing application layer. So the parameter groups that you are used to stay exactly the same. So there is no change. Then we maintain the controller, the application addressing or the ECU address scheme. We maintain exactly the same. So there's no change there. And we have, and this is really one of the design aspects, we have a native built-in support for functional safety and security. So this is really important. So this is really part of the protocol. And then what is also really worth to mention, because this was one of the requirements that especially comes from European OEMs, is that this new protocol can be met with AUTOSAR protocol stacks. It does not mean that every detail of the protocol is automatically enabled within AUTOSAR, but the CAN FD J1939 can be integrated by means of AUTOSAR mechanisms very easy. And so you don't need to tweak AUTOSAR too much to implement J1939 compliant communication. Of course, the transport protocols has to be implemented in a special way into AUTOSAR, no doubt about this, but 90% of the communication can be done within AUTOSAR stack without any adaptation to J1939, which is really great and allows manufacturers to integrate J1939 data links in their proprietary vehicle network environment very easy, very seamlessly. So this is really a major step ahead to have a broad base for J1939 applications. Okay, now let's talk a little bit about the parameter groups. Parameter groups stay, as I mentioned, the same. So we do not change the parameter group. However, we significantly change the way we transmit parameter group and parameter groups, and how we handle the assurance data, so data for security and functional safety. And here the thing is, in the classic J1939, we have the CAN ID, and then we have the payload, and usually we have a one-to-one mapping. One parameter group goes into exactly one CAN frame. And if we would like to transmit additional data for safety and security, then we used to have CRCs appended to the parameter groups, and then all this goes together as one pack into the payload, and that's it. And the limit here is certainly the 8-byte payload. And this limits the length of any CRC dramatically. And this does not really allow us to do state-of-the-art safety and security communication within the range of the classic parameter group definitions. And of course, it would be simple to enlarge or enhance the size of the parameter group, and then have a wider CRC or a larger CRC to have a better safety and security aspects. However, if we go above 8 bytes here, that would certainly kill the efficiency on the network, because then we would have to utilize a transport protocol for every single parameter group. And so this is a very limiting factor here. In the new world of CAN FD-based J1939, we have the old parameter group, and the significant change here is that the assurance data is an optional thing that you can add on demand or you can leave. So this is a option that the application will decide whether it needs or does not need assurance data. So this is one thing. It is not longer or no longer really an integral part of the parameter group. It is a kind of an add-on. You can add or you cannot add the assurance data. If you decide to do so, no problem, then this can be considered as a pack. So this goes together in the same CAN frame, so you do not have to utilize complex state machines and transmit assurance data in a different frame than your application data. And all this together goes into a large CAN FD frame, so the payload can be enhanced. So we are not limited to 8 bytes here. And the best thing is we can pack many or multiple of those parameter groups inside the payload. So typically the intention here is that we fill up the payload until 64 bytes are full of the CAN frame. So that guarantees the best efficiency on the network, and then we can fire this CAN frame and utilize the complete bandwidth of the network. And to do so, this is called the multi-PG transport. It's not a transport protocol because everything fits into one single CAN frame. So in the classic world, again, I don't want to stress this too much, you have the parameter groups, and all of those parameter groups goes into a separate CAN frames coming along with an unique CAN ID and then a payload. And the parameter group is somehow spread over the CAN identifier as well as the payload. In the new J1939 world, this is completely different. We really have the parameter groups and they go into the payload. And as you can see, you can have multiple of the parameter groups inside one payload. There's a CAN ID here, is either an 11-bit or a 29-bit CAN ID. This carries certain information. So one of the information certainly here is to tell the others, okay, this is a multi-PG transport protocol. And this is the way we expect that about 95% of all the CAN communication is done exactly by means of those multi-PG transport. And if we talk about these assurance data, then this is an optional part of each individual parameter group. So it is not that you have to do this by design or at the design point of the parameter group. Even a parameter group today that has not been designed to be to pay somehow respect to safety or security can be now added with these assurance data. So this is simply a package that you can add to the parameter group, and then it will be transmitted together in the same payload with the same CAN ID. So this is very simple on the receiver side as well on the transmitter side. This goes really straightforward. And if you are familiar a little bit with CAN FD, then you may know that the payload here is not scalable on a byte base. So the payload has always a certain amount of data, which may not necessarily always fill or can be filled up with the parameter group here. And therefore, if there is some space left, it's kind of a pity. But if there is really the way that there is unused space in the CAN payload, then this requires some padding to tell the receiver there's no data anymore. You don't need to care about this. So this is padding if required. And yeah, that's about the major change in the protocol. If you compare J1939 CAN FD with Classic, it's really the way of handling and transmitting the parameter groups and really adding those assurance data as an option. This really makes the design of the overall system easy as well of the ECUs. And then, of course, if we have more than 64, or we have parameter groups which are larger than 60 bytes, because this is the maximum size we can pack into a multi-transport frame, then we need additional transport protocols. And there we have extended the existing J1939 transport protocols. So the BAM is still available. However, it offers more option. So we have a increased amount of data, so we can transmit roughly 1500 bytes or 15K bytes in comparison to 1785 bytes with the classic approach. And what is really new, and it is very helpful if you think about diagnostics, so the DM1 message, for example, which has to be transmitted on a very frequent base, this will not block other BAM transport protocols anymore, because we can run now up to 4 sessions in parallel. So every node can run 4 BAM transport sessions in parallel. So one channel or one transport session is mandatory, the others are optional. We have safety and security capabilities. So there is a safety and security add-on that can be added or will be added at the end of the transmission, so that ensures that the complete transmission is safe. And what is also new is we have an end of message status. So this is a new frame that ensures on the receiver side everything is fine, and this end of message status, for example, carries the safety and security data along with it. So this is a more reliable protocol, and it is very helpful. And this is one of the, it's probably not the major change, but this really helps in practice. And then the other thing is dealing with the RTS-CTS transport protocol. There we have also improvements. It supports a larger amount of data, and it supports up to 8 sessions in parallel. It also has the same built-in safety security features like the BAM transport protocol. And so this is also a helpful extension. And it might be possible now that we can also download firmware or parts of the firmware, and we are not limited to this very tight amount of data. So we think this really helps for practical applications. And then, those are the major changes at the protocol level. And then we have also changes on the physical layer. I have summarized this on one slide here to just give you an overview. So this is what you can see, or what you will get. So we have a physical layer. It's pretty much, it looks like the same with the classic one. We have the slope, the arbitration baud rate of 500K, and the fast data rate with 2 megabits. You can use it with shielded or unshielded twisted pair. Both is possible. The cable, it is recommended that the cable has a jacket because of the twist of the cable to maintain this twist over a longer time. And then we can use up to 30 nodes, CAN nodes on the data link. And the overall size of the network is about 40 meters. However, the length here depends on the amount of ECUs we utilize. It can go up to 56 meters if we only have 2 nodes. So the length practically is somewhere between 56 and 40 meters in total. And then we can also have limited size of stub length of about 50 centimeter or half a meter. And there's a minimum distance that needs to be maintained between 2 nodes of about 30 centimeters. So those are on a glance the major physical layer conditions that we have to meet. We have termination resistors here at the end of the backbone, or there are 2 types of nodes. Type 1 node has no included termination, and I should write here type 1, and there exists a type 2, and there we have the termination resistance inside the ECU itself. But this is similar to what we have before, so there is no change. And those type 2 and type 1 ECUs, it shall be marked clearly from the outside that you can see if there is a termination resistance or not. And then, one last word. If I look to with respect to the timing, we can discuss a little bit about the migration scenarios. So we have heard about all those great features that comes along with the new protocols, and what are the issues, what are the challenges if we have to integrate those into vehicles. And so we have heard, due to compatibility issues, it is not possible to mix a classic J1939-21 So the classical CAN with the -22 document, the FD-based CAN on the same data link because of a classical CAN transceiver would not speak FD as a protocol, and therefore it would disturb. It is not possible, and the FD node will not utilize classical Ethernet, classical CAN frames. So therefore, it is not possible to use a native written or a classical node on a new world and a new node which is not specifically prepared in an old network, and because of the physical layer as well as the protocol layer. So this is simply not possible. And so in most likely, the J1939 committee believes it is very likely that you have for a certain amount of time two networks. One utilizes the network which supports classic nodes only, and there is a new data link which probably will increase over the time with all new nodes if there are new nodes available. And then you have to connect those two networks together. And okay, I forgot to click on the animation. So this is what I mentioned earlier. It is not possible to mix classical and FD nodes, neither on the new nor on the old network. And to connect those two networks together, for sure, you need a gateway which bridges between those two protocols and the physical layers. And what you seriously should consider, if you have to modify now your classic node in some degree, then you may consider, I call this is not an official term, I call this a advanced J1939 node, which is prepared to support both physical layers. So this will work. A CAN FD transceiver, including a CAN controller, which utilizes CAN FD as well as classic CAN, can be used here, and then a node can be used, the same node can be used on the classical network as well as on the physical, on the CAN FD data link. However, the software must take care. It supports both protocols, the classical as well as the new one, and utilizes each protocol on each data link, which is supposed to handle the new or the old one. But this can be a strategy, since the major aspects of the protocol are, I shouldn't say compatible, but we use the same addressing scheme, we use the same application parameter groups, and I guess the major part of your software here is based on top of your parameter group level, on the application level. And so therefore, you should be able to create such advanced nodes with some changes in the lower communication layers. And then you can prepare nodes, you can create nodes in a way that they can live on both networks. You don't need to maintain different approaches and maintain completely different hardware for both worlds. Okay, that's all I wanted to share here today. So on a summary, the CAN FD J1939 specification is available and already published, so you can start right now. There exists migration scenarios. As I showed, you need to consider this for your own product strategy. It will have an impact on the communication layer and probably no impact on the application layer. If you have already applications which suffer for safety and security reasons, then the CAN FD protocol is really addressing those issues. And the J1939-22 protocol approach, and this is a practical value that we measured with some prototypes, is about, in practice, is about 4 to 6 times If you really utilize a lot of transport protocols, which is unlikely, then you can easily double or triple this amount of time here. But on a realistic scenario, this is what you will gain if you switch from one protocol to the other. And you really should consider using basic instead of extended frames, because that gives you also additional gain of bandwidth of about 5%. It's not too much, but if you are tight, then you can consider this. And yeah, we have the enhanced transport protocol capabilities with multiple channels with a larger amount of data, and those transport protocols are way faster than the old ones because you need less frames for the same amount of data, and the inner frame space is also way less because of you have less frames. So transport protocols are significantly speed improved. Even if you now consider to use AUTOSAR on your proprietary network on your vehicle, this is pretty easy now to integrate J1939 data links, way easier than it used to be. And so that will allow you to use a single tool chain for your complete vehicle, including the J1939 with respect to AUTOSAR. And yeah, and inside AUTOSAR, you may know about this. They have a lot of these safety and security profiles there, and they are practical proven. And so you can benefit from them because, as I mentioned on one of my first slides, those ideas how to use safety and security is 100% compatible to the approach of AUTOSAR, so you can utilize all those AUTOSAR profiles on your proprietary J1939 or public J1939 network, and you do not have to reinvent the wheel here and think about safety and security from scratch. You simply can negotiate on one of those existing profiles and use them as they are. Yeah, that's all I wanted to share. Here are a few comments from the market that I collected over the time. So there's one from Andy Fleetstra. He is the SAE chairman. He sees the J1939-22 as the answer, and for all those requests coming from the industry, especially for the bandwidth. And then we have here from ZF Friedrichshafen, the J1939 CAN FD is a must to have a stable and efficient communication system to meet upcoming requirements. So especially if it comes down to safety and security, this is again, really a major pain on today's J1939 networks. And then, there's one from Daimler Trucks, from Tom Feller, North America. I would expect to see a AUTOSAR basic software component to support J1939 FD container PDU in the near future. This is certainly what the manufacturers of the AUTOSAR software components needs to consider to offer those support, because that would allow major OEMs to integrate J1939 in their existing vehicle way easier than today. And there is also from Quasar, from Brian Hennessy, that he also wants to express that this improved data communication for heavy-duty vehicles is a major step ahead. Okay, thank you for your attention. If you have any questions, I see I run out a little bit of time, but maybe we have room for one or two questions. Thank you.
Thank you, Peter. There's a question from Satish Kini. Can existing parameter groups whose length is greater than 8 and less than 60 byte, can they be sent without a transport protocol?
Yes, they can be sent with the new multi-PG transport. So if they a parameter group which is in the range from 1 to 60 byte can be transmitted in a single CAN frame.
And the second question is, the gateway or advanced J1939 ECU should buffer or fragment whenever possible?
So the advanced, the gateway, excuse me, the gateway is not part of the standard today. So if you are going to utilize such a gateway, you need to answer those questions by yourself. And the amount of, or the size of the buffer depends certainly from your from the resources that are available on the gateway. This is one thing. The other thing is, if a network, a classical node, is probably not designed to accept a large delay here. So if there is some communication which is seamless from this classical node to this FD node, and if a gateway would add too much delay here because of the gateway will buffer too long, that would certainly cause some application issues here. So the thing for the gateway is to find the right trade-off between latency and efficiency on the network.
Okay.
There's no measure that has been done by the committee, but this is certainly a very good question, and that you have to be that you have to answer if you design such a gateway in your system.
I would not call it advanced gateway. I would call it a smart gateway, and the smartness would be then to have optimized filters and not to have the entire communication on the classic J1939 network to the FD network and vice versa. So if you would limit the gateway functionality between these both, then there should be not that much buffers necessary. And this also would maybe then in a smart implementation and without causing too much delays from the viewpoint of an application.